it's just gone past 5:45, so let's begin. Last presentation of the day. How's everyone enjoying your night? Yeah? Awesome. All right, well, thank you for coming so late in the day to our presentation. It's combining Unity and Google Tango with Apple ARKit to create a unique AR experience for the city of Austin. Some introductions first. I'm Andrew Bell. I'm a delivery center manager and mobile XR architect for FiveOut, a creative agency. We're national, but our main development center is here in Austin. I've been with them for about 4 years. Jonah?
Yep, I'm Jonah Mancini. I've also mobile XR architect and have been with FiveOut for the better part of the last 3 years.
That's the agenda. Now this presentation is going to be a bit different to most presentations you're going to see here because it's going to be split into two parts. So basically, first we'll do a slide deck, a case study slide deck presentation, but then the second part, coincidentally, one of the fixed AR installations we did is actually right outside the front door of the exhibition center here, the Cat Metro downtown station. So for those who are still interested, you can, once we finish the slide deck, you can walk down with us, and we've got a few Tango devices so you can see it, the future Cat Metro downtown station in real life. But in terms of the case study, so I'll talk about the City of Austin's project goals, the bidding selection, why we went with Unity and Tango. Then Jonah's going to go into a deep dive about Tango, briefly touch on ARKit, and then we'll talk about some other challenges we ran into. And then we'll wrap up the slide deck and go downstairs. So first of all, what the City of Austin were looking for. So late 2016, the City of Austin sent out an RFQ to the Austin gaming community to build an AR app that basically showcases a specific portfolio of 7 city-affiliated EDD projects for which the city seeks to attract investment. So in English, basically the city wanted someone to build an AR app which could show foreign investors what future construction projects what the finished product would look like. They wanted 2 versions of the app. One was basically a tour guide version of the app, which wasn't on the Play stores. So an employee from the City of Austin would take the foreign investors to the construction sites and they can show them in person the AR. The second version was public and they wanted Android and iOS. Next slide, please. Jonah is going to quickly give you a screen share of the app itself before we move on.
All right, so as Andrew said, this application is a business application. It was looking to engage foreign investors to invest in the city of Austin, right? So standard user interfaces that you would find on a regular business application or an enterprise-grade application is what we were looking to achieve. So we've got our map here, we've got a side menu for navigating, and we have, when clicking on any given marker, we have this slide-up drawer. You click on then you can get more information. Here specifically about the Cat Metro downtown station. Additional information. We have this AR button that you can then click to then engage in the augmented reality experience. Ultimately, the whole point of this application, though, was this send me information, send me investment details, and where I would then go and fill out my information. I'm interested in Cat Metro. I would like to see it succeed. Tell me how I can become involved. So I've got this form here. Standard. We've all seen 101 applications like this, right? And this is actually one of the primary challenges that we encountered when building out this application, which we will visit here further in presentation here. Let me go and switch back over to Andrew here.
All right, so the bidding selection. So with the huge success of Pokemon Go last year, a lot of organizations came to believe that really only gaming studios had the skill sets to develop AR. So we actually only discovered this RFQ because we're members of the Austin Unity meetup community and it was posted in the forum. So I saw it in there. It wasn't it wasn't sent out, it didn't come through our usual channels, so I took it upstairs and we decided to submit a proposal. One of their requirements was the developers had to be local to Austin, so we had that in our advantage. Speaking to the City of Austin after we won, they said one of the standout differences was the professionalism of our submission. That's probably an advantage we have over game studios or indie game developers. That's not a slight on those guys, but at being a consultancy, we submit proposals for RFQs and RFPs every day. So we have a lot of experience with it, and we've become pretty good at it. One of the final steps in our selection, we had to prove our VR and AR experience. Personally, I have more experience with VR than AR. I did a lot of Steam VR and Google VR. Jonah and I have competed in some local jams and some global jams. I've only been doing AR for probably the last 2 years. Jonah's probably stronger in AR than I am. Jonah?
Yeah, well, one of the reasons Andrew is actually more proficient in VR is because he actually put the money down and bought the Vive. And I just go and hang out with him and get to play with it. But yeah, so I've been doing augmented reality for the better part of the past 5 or 6 years. Before I was with FiveOut, I worked for a museum. We did a lot of interactives, leveraging augmented reality, some early forms of Vuforia when it was still under the Qualcomm umbrella. Also, the museum had produced some curriculum, and we had augmented these textbooks to create a more engaging experience for students and things like this, making the material come to life. And then since then, a lot of additional things here at FiveOut.
The final point on this, unusual for an RFQ, they actually put the budget in the RFQ, which you usually don't see, and it was significantly lower than the effort required for what they were looking for, so we had to make a commercial decision to basically develop it at cost. We made no money off it, but we thought it'd be an innovative app to add to our portfolio, so we decided to press ahead with it. Platform decisions, well, we chose Unity and Tango. Unity, first one's obviously a no-brainer, it's cross-platform. Having to develop separate code bases for Android and iOS doubles your development time, well, close. And because we're already making no money on it, why make it worse? So obviously decided with a cross-platform platform, that makes no sense. Any AR framework worth its salt obviously has a Unity plugin, so easy SDK integration. And as we touched on before, Jonah and I have a lot of experience with Unity, so we already had that skill set. Only real con we had was creating a business acceptable non-gaming mobile UI, which matches materials design and also iOS native UI. Took a lot more development than if we were using a mobile specific framework like Ionic, but we're going to get into that a bit later. So before we get into why we chose Tango, we should probably look at where AR technology was at around the time this proposal came out. The challenge we had was to position a virtual building with the exact location, rotation, and scale and depth of where the real world building would be positioned once constructed. So you have to remember, this was before ARKit, ARCore. So AR's come a long way in the last 12 months. True markerless AR for mobile, basically AR that can recognize a real world plane with good accuracy has only really been around the last 12 months. So options were basically marker-based, markerless estimated horizon like what Pokemon Go uses, location-based GPS, or Tango. Anyone who's been doing AR for more than 12 months will recognize that marker on the screen. Basically, you put the marker on a surface and the AR model will appear above it or next to it, whichever rotation you use. Considering the size of these models and where they would be located on construction sites, this wasn't an option. We can't put a marker in the middle of a construction site and have people stand on the edge of the construction site trying to find it. Obviously, it wasn't going to work.
Yeah. One of the clear benefits, though, of using marker-based AR is that the technology knows a reference point of how big something is in reality. So if you wanted to then superimpose a three-dimensional object and have it be to scale, this was a relatively good route to go. But as Andrew mentioned, it wasn't really an option. It wasn't a viable solution for us.
The next option was markerless estimated horizon. So basically uses the phone's gyroscope to estimate where the virtual world horizon would be to try and line up with where the real world horizon would be to match the planes. It does a kind of good estimation, but it wasn't exact enough. And also the problem with just using markerless estimated horizon is the closer you moved, as you walk towards the object, it moves away from you. We needed something at a fixed point. So they bring us to location-based using GPS. Unfortunately, as we all know, GPS is only accurate to within a few meters. So we needed something pretty much a lot more accurate than that. And a big problem with just using location-based is the rotation of the object. You'd have to be standing in an exact point to get the rotation correct. If the user was standing 10 meters to the exact point, the rotation would be off and get worse as they moved around the building. We could have combined the markerless and location-based, but we'd still have the problem with scale and depth. I'll just go do a high level of Tango, and then Jonah is going to do a deep dive. But basically, for those not familiar with Tango, at a high level, it's got motion tracking, area learning, and depth perception. Motion tracking is just, as you've seen in the AR core talks, the phone knows where it is in 3D space. Motion tracking alone, while the device sees the visual features of the area, it doesn't remember them. So area learning basically remembers what it sees, and so when you come back previously to a previously saved space, it'll remember the area and know where the phone is in relation to that area. And depth perception sounds exactly how it reads. It's the ability of the phone to understand the distance to objects in the real world. The big downside with using Tango was very few devices still today are Tango enabled. At the time, there was actually no Tango devices available. The Google Tango tablet had stopped being sold, so we had to time our development to start on the week that the Lenovo Fab 2 Pro, which is the first Tango phone, was released. And also, as we've now seen, Google has a habit of discontinuing promising technology, and we now see that Tango is kind of being phased out for AR core. Have you got anything to add on that?
Yeah. Other than a slightly broken heart. No, after having many conversations over the while here, I have a lot of hope for what AR core is bringing, and my understanding is that a lot of the underlying technology, underlying algorithms and things that were built during the Tango process is going to live on under the hood inside of AR core. So that's certainly promising. Let me go ahead and kind of dive into Tango a little bit more. So how many of you have played with Tango in the room here? Just so I know, kind of get a gauge. All right, so that's a little bit more than half. So I'll quickly run through this. Tango is kind of a pairing between both hardware and software, right? So hardware with some additional features, specialized hardware. We've got a standard camera, what I'm calling a motion tracking camera with the fisheye lens, where you can get kind of a panorama view so you can track a larger number of points of interest and things like that. There's also the infrared camera and the infrared projector or emitter, which are both used together to gauge depth with a structured light array. And basically you get a bunch of infrared dots that are projected out, and based upon the size of those, as they bounce off of objects, you can gauge things, or what's called time of flight, measuring based off the speed of light, and as it travels from the phone and back to the phone and picked up, you can gauge where and how far things are in reality. This is really, really powerful, right? So the software pieces, Andrew had mentioned kind of at a high level, the motion tracking, and if you've attended the Google AR session just previously before this one, or so you think you can augment reality, they're both wonderful explanations of kind of how this technology is working, right? using this VIO, the visual inertia odometry, to estimate kind of where the device is in reality, taking 2 images and gauging based upon where those 2 images are as the device has moved through space, finding fixed points of interest, and saying, oh, this is an interesting point, and based upon the difference there, it can understand where the device is, how it's oriented, where its position is. Adding on top of that, as we've seen the accelerometers and the gyroscopes, to get all of these pieces together to try and understand how the device is positioned and oriented. Now that's only halfway there, right? That gives us our motion tracking. But what it doesn't do for us is there's some clear limitations to this. It doesn't remember the environment. It doesn't know about the environment. It knows about itself, for the most part. And it seems like some of the newer technology or the newer algorithms that ARCore is kind of unpacking is they're able to leverage some of the algorithms in the motion tracking to also then begin to understand what the environment is like. Well, where Tango has an advantage over that is it has a depth sensor, a depth perception capability, right? So it knows where things are simply by taking measurements of how far they are from the device with the infrared camera and projector. Now, if you bundle that all up with area learning, which is essentially the memory of the space you've moved the device through, you essentially are building a 3D representation of the environment, of objects in the environment, objects moving in the environment where walls are, as long as these sensors can't interact with them. Unfortunately, some of the limitations here are the infrared projector couldn't reach all the way across the room and bounce back. Or say if there's too much infrared light in this particular area, like if the sun was shining in this room, which happens to be rich in infrared light, it becomes difficult to kind of capture some of those pieces. I want to talk a little bit more about the area learning and answering this question of where am I? So first of all, we have to understand what a pose is. The pose is basically if you ask the question, where are you? Where are you, Jonah? And I'd say, well, I'm standing on my head. And that's essentially what a pose is. I'm standing on my head. I'm letting you know that I am oriented so, and my position is just such. But we don't have a reference point, right? So this is our pose. But then to really understand where I am, we need a reference point, a place to refer to. So if I say I'm standing on my head just north of the Capitol building, that's a lot more helpful. Now we have an understanding of where I am. So we have these frame of references, and this is how Tango kind of operates. We have a base frame that's established with the kind of the startup of the service, of the Tango service, and then as the device moves around in space, we then have a target frame. And we have kind of a comparison of those two coordinates, of those two locations, and you get an understanding of where you are kind of compared against all these information that we're getting from these sensors, right? And where this becomes super powerful is when you pair it along with an ADF. An ADF is an area description file, right? This is that 3D mapping, this 3D representation of the space that the Tango device can now recall. So it's like, not only am I just north of the Capitol building standing in my head, but here's a map, and this is the Capitol building. That's essentially what the ADF is. It's now a map that we all now know and understand, so I can put a pinpoint accuracy of where I am in space. And as I continue to move around, this will update. So this is really, like I said, how the Tango technology was shining. As you would place an object in space, you'd walk away from it. And as you'd come back, because you already knew what the environment was like, that object would stay right where it was. And other problems that would happen with motion tracking, like drift over small areas, small errors over time and distance, could be corrected because you'd be constantly making these updates against this area map, this area description file. On our particular project, our solution was tightly wedded with the project developers. All right, so we're leveraging the Tango tech.
Sorry, and when we say project developers, we don't mean coders, we mean...
People who are building buildings,
yes.
Essentially, right? So our solution was tightly wedded with them. Basically, we weren't creating anything. They were choosing the locations because they were building on sites that they had already purchased land for or for whatever reason. And they had the 3D models. So we were creating nothing. We had to take all of these things and then try and get them to work together in a reasonably reliable way in an augmented space, right? So this came down to what the 3D models. And I was kind of expecting a lot of CAD files and or maybe I'd be getting FBX files and things of this sort that I would then have to kind of like, all right, well, how are we going to translate this into the augmented reality space? Like, I was concerned about scale and keeping proportions accurate. A lucky happenstance was all the developers we were working with, the project developers, they were using SketchUp, and all of their models were in SketchUp. And Unity has a wonderful way of importing SketchUp models and maintaining scale for us. So this really streamlined the process. So, like, I'll have to flip the switch. So I'm going to switch over to the Unity environment here. These are one of our models that we imported directly. And they're not small, right? So we should all recognize this location. This is the convention center where you are right now. We are technically right over here. And in the future, this metro station is going to be moved from its current location, which is a little bit further this way. And there's going to be a sky bridge walkway connecting the hotel across the street to the conference center. And there'll be more metro lines and these wonderful shade.
Parasols.
Parasols, thank you. Shade providing works of modern art, right? So, and they're lovely. And the nice thing was that we could just take it and just kind of drop it into Tango. Once we had our augmented reality environment running and we had the area description file all built, we just dropped this model in. It was the right size and everything. The only problem we then had was, how do we get that model to be right here, just such? So in order to do this, what I did is I created a second set of UI elements that I then used to help me position it in space. Let me go ahead and kind of turn them on here. It's oriented a little bit to the side, or all the way to the side, I should say. But yeah, it's just basic. I can move my models up or down or forward or backward to the right or left, rotate it slightly. And then when I was done, I would then spit out the coordinates in relationship to my ADF. I would record that, I put them into a JSON file that is loaded up real time when the app is running, and then as soon as we get a pairing with the Tango area description file, it would just snap right into place, like magic. And it was wonderful because we had this massive block-sized model that you can walk around, and things just stick to where they are. So super exciting in that sense. Now this was a viable solution for the city of Austin, primarily because they were going to be taking walking tours. They will be taking investors. And they can take the Tango-enabled device and walk to the site, walk to the location, and show them around, right? So Tango is a really good solution here. One of the other issues or challenges that we came up against was the sites, right? They're outside. These are large areas and sometimes featureless. This is one of the other locations that we had to fit a future development project. And there's not a lot here. There's an open field, there's a fence, there's a road. Tango doesn't do too well if there aren't many things to identify. Everything just looks relatively featureless. So how did we tackle some of these problems, right? And also, like I said, it's outside, so it's an infrared-rich light environment. So some of the sensors weren't going to operate as well. So what we did is we revisited these sites and created multiple ADFs, extended ADFs, at different times of day, and trying to stick around areas where they were a bit more feature-rich. And I think we came up with a pretty good success. Ultimately, like say, for example, here downtown, we chose a location to kind of direct the tour guides to say, look, you can get a pair with your ADF anywhere up and down this street, but it's going to be most reliably, the pairing will be most reliable at this particular location. And so we kind of guide them in these areas where there are more features, where there are, the lighting is a little bit better controlled. And so now let me talk a little bit about the future of Tango. I hit on it a little bit earlier. But the future of Tango still is a good solution for this type of application, where we don't need millions of users to be able to take advantage of this. We have a targeted audience in a targeted scenario, right? So here, 4 or 5 devices is enough. And that's not too much to ask of a, let's say it's something like the city of Austin or another design firm or something like this to make presentations with. They can have a couple of Tango devices on hand, right? We don't require the masses to own them.
Yeah. So basically, Tango apps are more suited to non-public apps, more private apps in the enterprise.
Right, and so another thing that we ultimately did is we incorporated ARKit to try and accomplish some of the same things. Because of when it was released, I was playing with the beta. Like, let's try and do this. And we leveraged the Unity API for this. It was very accessible. It was a paradigm shift for certain because of the different prefabs that I was used to working with and kind of the way I was thinking about things with Tango. And when we switched over to ARKit, it was great for only using just the camera that you find on the back of an iPhone. Ultimately, I found myself really struggling because it wouldn't solve the problem of situating an object in 3D space and having it stay there. Ultimately, and this is, I've got it running here on this device, we chose to not have the ARKit solution try and put the model in context because the movement was just too much. It felt like it was a problem. It felt like it wasn't working. So the way that we've implemented the solution with an iPhone with ARKit is we'll just have the object appear in front of you. And I can actually just show you that now.
So when Jonah says not in context, it means basically the model will appear wherever you are.
Right, so we're obviously not outside, but we can see there's the train station. Normally I would have it sideways. It looks great to me, but it doesn't look very good to everyone else over there. We didn't have to worry about orientation on the applications because it works well on the device. The 3D space kind of would be tracked just fine with it. So yeah, we can see if we look up, there's the sky bridge above us, connecting the hotel across the street.
Now, obviously, using Tango and in context, actually at the location, it's superimposed where it's supposed to be, it's obviously a lot more impressive.
Right, so let's go ahead and, the last bit of challenges that we encountered were using Unity and standard UI best practices, right? So because it's a business application, there are expectations when it's on a mobile device of how the user interface should respond. Android devices should behave like Material Design. iOS devices should behave according to Apple's design standards. And when we were building this out, I mean, there were a couple plugins that we encountered on the Unity Asset Store, things that we tried out, but we found that a lot of them were very old or weren't supporting some of the newer Unity environment that we needed in order to take advantage of the newest features in Tango. So we found ourselves needing to recreate a lot of these basic user experiences, these user interactions on the device.
At one point, we even considered just creating a whole lot of web views and putting Ionic on top of the web views, but then we decided it was just going to be too much complexity. Right.
So then this is kind of a point we kind of ask is like how viable is Unity for producing a business or enterprise-grade application? I think it's very viable, right? But right now, there are some set standards out there that I would love to see kind of implemented in Unity that would afford basic mobile interactions that we're used to, right? The way transitions happen from screen to screen. Yeah, so just a lot of these pieces. And I think that's more or less what we had planned on talking about. I think the next stage of this, if there are any questions, you're welcome to pop out the aisle and to the microphones and ask some questions. But what we had intended on doing was then taking folks who were interested right out to the front of the building and allowing people to play around with the Fab 2 phones, Tango-enabled devices, with the CAP metro station right outside.
But for those of you who don't want to come or think it's time for a bit of drinky winky, thanks a lot for coming. We really appreciate it. Does anyone have any questions? Could you please step up to the microphone?
How's it going?
Hey.
If you were going to do this again today, what would you do differently, knowing all the shift from Tango to all the new technology out there today? How would you change what you did and kind of move forward?
Yeah, that's an excellent question. To be honest, I would still choose the Tango technology. Because like I was saying, it's not en masse. It's not something that needs to be done on scale. And there just really is no solution out there today that is as good at establishing and maintaining three-dimensional objects in an augmented reality space.
Yeah.
So.
I mean, Google aren't discontinuing support for Tango. There's still Tango devices out there. It's just going to be very limited.
And we'll see as sensors, maybe there'll become a new set of sensors that are standardized across all devices, and then we'll see Tango come back, or those sensors to be leveraged by what used to be Tango, right? Yeah, go ahead.
So I just tried your app. It's not working on my phone. Is that because my phone is not Tango compatible or something like that?
That's why. I mean, sorry, some clarification. The rest of the app works, but not the AR.
Yeah, not the AR. That's the part I wanted to take a look on that.
Yeah.
Okay, so in the future, it's like you said some of the technologies on the Tango will be kind of umbrella under the AR core.
Yeah.
Is that in the future AR core compatible devices will be able to see the AR thing, or?
We are considering it. It's going to depend on if the city of Austin want to pony up a bit more money.
I know. It's hard to get money from the city. I know that.
But not only that, though, there still, even with AR Core, there's a select list of devices that
right now
that can run AR with AR Core.
Right. So. I think Google's plan just heard the AR talk that their next goal is to reach out to 100 million devices that support AR Core, right? That will help this greatly.
Yeah,
for sure.
Absolutely. But again, when we're using AR Core, just like ARKit, it won't be in context because we just can't get it accurate enough. So it'll be like, as Jonah showed you, the AR will just show up wherever you are.
Yeah, and look, honestly, I mean, I plan to play around with it to see is how far can we take AR core? How much can we leverage? If I have an existing area description file, can I leverage enough of the AR core stuff to make it work well? I don't know, we're going to see. We'll play around with that.
Next.
Yeah, as a fellow Tango developer who has had some successes and failures, the Tango service not available that you probably saw
A lot.
So the unstable development environment in which Tango was in there for about a year and a half, and that we all saw and dealt with, and it sounded like you used ADF saving and loading, and it's a great tool, and I agree in the use cases that it's superb. Have you, I guess as a fellow worker in this, have you noticed since AR Core came along that you've experienced any kind of problems with ADF and Tango's core failing a lot? Yeah,
that's a good question. One, and that was we upgraded to Unity 2017.1, and
it stopped working.
Right.
Like, well, wait, what? I can't do what?
Right.
Why is the app just crashing on the device? Some forum digging and find out, like, oh, okay, let's downgrade. Apparently, some of it's supposed to be in the beta 2 or maybe general release for 2017.2.
Yeah.
Okay. And you said you talked with Google. Did ADF come up at all? Like, is that going to be continued to support?
Yeah, I mean, they aren't doing away with ADS, because they're not doing away with Tango, but continued development, I'm not sure.
Yeah, I mean, let's just say I'm hopeful. From what I heard, it sounds like there is some real potential. It doesn't sound like they're abandoning it just yet. And so we'll see what it comes down to in the future.
Okay, thanks.
Thank you.
Yeah.
You said how ARKit couldn't quite live up to what the Tango is providing in terms of true localization.
Yeah.
I'm going through that exact process right now. Could you tell me some of the examples of things you tried to get it to lock in that failed so that I don't repeat your mistakes?
Well, to be honest, I didn't try super hard because we had a solution that worked really, really well. And I didn't need to provide the city of Austin with an iPhone. They were perfectly happy with the Tango devices, and it was going to be better no matter what. But that which I did try, plane finding, situating it just so. Considered trying to do some marker-based stuff to try and help, because right out front there's this wonderful giant star embedded in the cement.
Yeah.
That I thought, like, well, maybe we could use that as a marker. So that was something like maybe kind of a couple things in tandem to try and bring it together. But yeah, it was more just kind of brainstorming at that point. I didn't actually try much beyond that.
Okay, thanks.
Thank you.
Sure.
Hi. Two questions, I guess. In terms of the rendering of the virtual space, is there any, or do you guys think about any kind of environmental function for, like, if you're looking at the place at night, or kind of like, measuring light or measuring anything to then change what you're looking at?
Yeah.
And then I guess just ask the other question is, how does it look from the inside? Did you, since it's SketchUp, I assume you can walk through that space too.
Let me take the second one first, and you can answer the first one.
All right.
Sure. So because the budget was so low, we basically just had to accept the models we got from the construction developer architects. Some were better quality than others. The Cat Metro one, look, it's a bit bland. It's not too bad. So as you walk through and you walk through the train, you'll actually walk inside the train. It's not detailed inside the train, but
it's fun.
Yeah, yeah. So it really depended on what we got from the architects. If the budget had been a lot more, we would have done our own work on the models, but the money just wasn't there.
So it would be possible to see the interiors if you had modeled the other side and furniture and stuff.
Yeah, it's actually walking through it. It's still quite fun, actually just walking through a train. So we could have done it. Yeah.
And kind of to piggyback on that same response, aside from budget constraints, I mean, I gave a lot of thought about environment lighting. If we could somehow leverage even the front-facing camera to gauge where the sun was and based upon the time of day, if we could cast shadows and change environment lighting based upon the ambient light detection stuff. So yeah, I've given a lot of thought of it, but because of budget constraints and time constraints, didn't do too much. I mean, we wanted a lot to make the models look a lot nicer.
Yeah.
They're quite simple as far as what, like texture and light mapping and all this stuff. They're very simple. So yeah, adding like a proper environment would be great. A wonderful addition to it, I think.
And in terms of different times of day, we also captured ADFs at different times of day to adjust for the different lighting scenarios in different weather.
Yeah.
Yeah, I mean, we tried to get it, yeah. That's, I mean, that's about all we could have done.
So that was done more just so you got an accurate position
Yep.
at any point?
Yep.
Yeah, as long as there was light. At night, unfortunately, is just really, really difficult.
Yeah.
I've been lucky, and I've had it pop up, but most of the time it doesn't.
Yeah.
So infrared doesn't, the distances aren't enough to
Yeah,
position?
and we're not getting enough information from not just the depth sensors, but also the other two cameras.
Yeah, I mean, as Jonah touched on, Tango is really designed for smaller indoor spaces. I don't know anyone else who's tried to do it at this scale outdoors. So yeah, we certainly ran into environmental challenges.
All right, thanks.
Yeah,
No worries.
thank you. If there aren't any other questions,
Yeah. So we'll just pack up, and anyone who wants to follow us down to the front is welcome to have a look. Or otherwise, thank you for your time.
yeah, thank you so much.